So yesterday, we started to talk about how we can prove that triangles are congruent. And yesterday, what I told you is to prove a triangle is congruent, you have to prove that all three angles are congruent and all three sides are congruent. And if you can show that, you can say, okay, the triangles are congruent because that's the definition of congruent triangles. All the angles are congruent, all the sides are congruent. What we're going to find out today and into next week is that you don't necessarily need to show that all of the angles and all of the sides are congruent. We're going to learn a bunch of different postulates and theorems that will kind of set a criteria that says, okay, you don't have to have all the angles and all the sides. You could maybe just have this specific angle and these sides, or this specific side and these specific angles. Some combination of angles and sides that you can have to prove that the triangles are congruent. So we have two postulates today. Before we actually talk about the postulates, I want to ask you guys if you remember, beginning of the year, at the beginning of the year, we talked about the difference between a postulate and a theorem. Does anybody remember the difference between a postulate and a theorem?
Postulate is one that can prove it.
Opposite. You can prove a theorem. And we did that yesterday, right? The third angle theorem, we went through that proof. And we did a formal proof to show if you know two angles and two triangles are congruent, we proved that the third angle has to be congruent as well. Now notice today, we have postulate 4.1 and postulate 4.2. This just means that we assume these things are true. It works every time, but you can't go through a formal proof. There's no way to write out a formal proof to prove the same side postulate or the side angle side postulate. It just works every time. And until somebody can show a counterexample, we're just going to assume that it works every time. So keep in mind that we can't prove that these are true, but it has been shown for a long time now that it is true. So the first one is called the side postulate. So basically, instead of having to show that all of the angles are congruent and all of the sides are congruent, if you can show that all of the sides are congruent, that's enough. That's enough to show that two triangles are congruent. So for example, we have these two triangles here. So if you know that side AB is congruent to side DE and side BC is congruent to side EF, and AC is congruent to DF, or DF. Okay, so you have three sets of congruent sides. If you can show that the three sides are congruent, that's enough to say then triangle ABC is congruent to triangle DEF. You don't have to worry about the angles. It's been shown time and time again that if the sides are congruent, the angles are going to be congruent too, so you don't have to worry about the angles. So what we're doing today, although we can't prove that this postulate is true, we can do proofs using this postulate. So whenever I say there's a ton of proofs, and there's 4 proofs today, you guys are getting ready to see that this is what the proofs look like today. Way simpler. So for this proof, let's talk through this. Okay? So what we've been given here, we're given that LM is congruent to NP, LP is congruent to NM. I want to prove that these two triangles are congruent. So we can use side postulate to prove that. They've already told me that 2 of the sides are congruent. I just have to show that the third side is congruent. Well, the third side is that line down the middle. How are we going to show that the third side is congruent? We did it yesterday. It's the reflexive property, right? It's the same side in both triangles, right? It's LN in that triangle, and it's LN in that triangle. It's the same side, right? So all we have to do is say, okay, well, LN is congruent to LN because the reflexive property would prove it. Okay, so it's going to take 3 steps, all right? So in our proof here, we, of course, are going to have our column for our statements and our column for our reasons. And of course, our first statement is going to be the given. LM is congruent to NP, and LP is congruent to NM because it is given to me. So the given takes care of two of the sides. But side, you gotta do the third side. Well, we talked about that. The third side, it's the same side in both triangles. So all you have to do here is say, well, LN is congruent to LN. It's always congruent to itself. So if it's the same line in both triangles, we know that it has to be congruent. And this was called the reflexive property of congruence. Let's be a little more specific than just reflexive. It's the reflexive property of congruence. So it was given to me that these two angles are congruent. Well, I just showed that that third angle is congruent. So guess what? If we have three congruent angles in two different triangles, those triangles are going to be congruent. So your last line is always going to be that proof. Triangle LMN is congruent to triangle NPL. And your reason is just going to be the side, side, side postulate. So you can just write SSS. Okay, this is more along the lines of what the proofs are going to be like this chapter. Okay, are we a little less intimidated maybe by proofs? Maybe a little bit? Okay. Now let's talk about the other one. It's going to be kind of along the same lines, where this one says you just have to have three sets of congruent sides. The side angle side postulate says you have to have two sides and an angle. But here's the thing. It's not just any two sides and any angle. You have to have two sides and the included angle. What I mean by the included angle, okay, down here, AB and DE are congruent, AC and DF are congruent. It has to be the angle in between those two sides, okay? It couldn't be angle C and angle F. That wouldn't work, okay? It has to be that included angle. So, for this one, if AB is congruent to side DE and side AC is congruent to side DF, so we have our two sets of congruent sides, then you have to have, once again, it has to be the included angle. So it has to be angle A congruent to angle D. If you have two sides that are congruent and the included angle is congruent, then we could say, okay, the triangle ABC is congruent to triangle DEF. That's all you need. Two sides and the included angle. So let's do the same thing. Let's jump over here and let's see if we can prove that these two triangles are congruent using side angle side. So this one, once again, kind of talking through it first, I think it helps to talk through it first. They tell me that AC is congruent to EC, BC is congruent to DC. I want to prove the triangle ABC is congruent to triangle EDC. So they tell me I have two sets of congruent sides. I need a congruent angle, but remember, it has to be the included angle. It has to be the angle in between those two sides. So it has to be this angle and this angle. Okay? It wouldn't work if you did like these angles. Okay, yeah, they're corresponding angles, and if the triangles are congruent, they're going to be congruent. But to use side angle side, it has to be these two angles right here. How are we going to show that those two angles are congruent? Yeah, they're vertical angles. And vertical angles are always congruent, so that's kind of our game plan here, okay? So, for our proof, we have our statements and our reasons, and hopefully we're getting this part down. What's my first statement going to be? The given. We know that AC is congruent to EC, BC is congruent to DC because it's given. Those are my two sides for the side angle side. Now I have to say that the angles are congruent and how I know the angle is congruent. Now, to name the angle, it's been a while since we've done this, really talked about this in class. I'd like to name an angle C, but unfortunately I can't because there's a lot of angles right there at C. So you're going to have to use your 3 points. So if I wanted to name like this top one, how would you name that top angle? A, C, B. Wherever you left it, it would be. So we could say angle A, C, B. You could also say BCA, mean the same thing. But that is congruent to, what's one way you could name the bottom angle? DCE or ECD. It does not matter. Let's call it angle DCE. And we know that those are congruent because they are vertical angles. So we were given the 2 sides. We now know that the included angle is also congruent. So we have a side, an angle, and then a side, which means we know that these 2 triangles are congruent. So your last step is always going to be that proof. Triangle ABC is congruent to triangle EDC. And your reason, side, angle, side. There we go. Okay, how do we feel about the proofs? Not too bad, right? Okay. All right, let's get this glued into page 51. This is section 4.2 called Triangle Congruence by side, 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 and side, angle, side. Let's start first by looking at some sets of triangles and by the information given, see if we can decide if they are congruent. So, 4th hour yesterday gave me a real hard time about my pictures. So, I'm going to do better. Okay, first one. We got a right triangle down here. So they're going to tell us that's a right angle. And then one up here, also a right angle. It's a good picture, right? Yeah. Pretty good. Yeah. Okay. The bottom and top have 1 hash mark, and then the left and right are going to have 2. So if this was the picture you were given, you just have to decide, do I have enough information to prove they're congruent? Remember, I don't have to know that every single side and every single angle are congruent if I either have a set of 3 congruent sides or a side, then an angle, and then a side. I have enough information. Do I have either one of those? Which one? Side, angle, side. Yeah. So I do is SAS. Exactly that. Side and side. Okay.
We have an apple pie too.
Thank
You're
you.
welcome.
Oh my gosh, did you make this?
Yes, I did.
Looks wonderful. Thank you. Okay, number 2. All right, here we go. Looks like this. 2 tall triangles. Okay, the top angles are congruent. The bottom sides are congruent. If this is all I give you, I either need 3 sets of congruent sides or a side and then an angle and a side. Do I have either one of those? No. So this we'd say either. There's just not enough information there. They may be congruent, but from what I've been given, just not enough information. Okay, number 3. Okay, here we go. These are the ones that give me a hard time. The little sideways ones. Oh, that's good. Yeah, those are good triangles right there. I'm proud of myself. It's awesome. Okay. Okay. So the tops are going to have 3 hash marks. These inside ones have 2, and then the last one has 1. Just sitting here admiring my triangles. It's really good. Okay. Do I either have 3 sets of congruent side or a side and then an angle and then a side? What do I have? I have side, side, side. I have 3 sets of congruent sides. This is all you're doing on the front side of your homework. Okay? Let's do one more of these. Alright, so okay, we're gonna do that one. There we go. Scooch this over. Practicing for 4th hour. Okay, here we go. Okay, so this inside angle is congruent. The bottoms are congruent, and then these outsides are congruent. Okay, remember, I either need 3 sets of congruent sides, I don't have that, or I need a side and then an angle and a side. It's neither. Why is it neither, Leo?
Because the angle has to be between both the sides.
If this was angle, side, angle, that congruent angle would have to be the included angle, and it's not! Sam actually said what this one would be, and it's not actually a thing. What would you call this one? Angle, side, side. And we don't use angle, side, side, because angle, side, side. You guys get it? Do I need to, I'm not going to spell it out. You got it? Okay, okay. We don't use angle, side, side. That's not a thing. I know. Okay, there we go. Okay, no, it's not the included angle, so there's not enough information there to prove that that's congruent. Yeah, okay. Okay, questions on that? Okay, let's talk about our proofs. Here we go. Okay, number 5, our given, and I think it's like yesterday, probably just going to be easier if you do your best to just copy it down while I say it. Might be easier. Okay, so RS, side RS is congruent to side UT. Side RT is congruent to side SU. We want to prove that triangle RST is congruent to triangle UTS.
Excuse the interruption. Students and grandkids who are over at Grandparents' House should be back in class. Hopefully they are headed back to class or should be back now. Power School is back up and running, so teachers, if you want to go ahead and take attendance for 3rd hour at this time, you certainly can. And anything you need to add into Power School now will be saved. Thanks, everybody. Beautiful Grandparents' House. Thanks, everybody, for all your help, especially our BCPO who helps with the reception, our choir, our band, liturgy, club, Father Ed, etc. Thanks, everyone, for a wonderful Grandparents' House.
Okay, so you guys kind of get the picture drawn, yeah? Okay, so RSTU. Most of the time they're gonna label and mark the diagram for you, but if they don't, I like to label and mark the diagram. That helps. We have RS congruent to UT, RT congruent to SU. Now the 2 ones that you can use today, either side, 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 or side, angle, side. They give me 2 sets of congruent sides, so I either need the included angle or the 3rd side. Which one do you think we could do? The 3rd side, right? Yeah, this is the 3rd side, right here. Okay, so this is going to be that reflexive property of congruence. So let's jot down this proof. So we've got our statements, our reasons. Our first statement, as always, side RS is congruent to side UT. Side RT is congruent to side SU because it's given to me. So there's 2 of our sides. What will I say to show that the 3rd side is congruent? Reflexive, and that's going to be my reason, the reflexive property of congruence. What's my statement going to be? Elijah? TS, side TS is congruent to side TS. Well, we said ST, that's fine. It means the same thing. Okay, so I have 3 sets of congruent sides. 2 sides that came from the given, 2 sides that came from my second statement, which means, remember, your last statement is always going to be that proof. Triangle RST is congruent to triangle UTS because side, side, side. too bad, right? I mean, kind of like a little bit fun, right?
Now it is.
Oh, I know, we should have started with these proofs. Okay, let's do one more. Okay, number 6, the given segment GK bisects angle JGM. GK bisects angle JGM. And GJ is congruent to side GM. And what we're trying to prove is that triangle GJK is congruent to triangle GMK. Okay, here's what our diagram looks like. I'm really good at drawing these ones. So I got these ones down. Look at that. That's like perfect. If I must say so myself. Okay. G, J, K, M. Like so. And then I like to mark these. So we'll come back to this GK bisects JGM. I can kind of mark that away, but let's mark the GJ is congruent to GM. Now to kind of talk about a game plan, I know I have one set of congruent sides. How is that GK bisects JGM? How is that going to help this? What does bisects mean? I guess I'll start there.
It splits it evenly in half.
Splits it evenly in half. So this big angle is now in 2 equal parts. So what do you know about these 2 angles? They're congruent, okay? So we are going to have to state that because it's given, but we have to say, okay, because of that, these angles are congruent, okay? So we're going to have to state that. But what I have is a side and an angle. Can I prove that that side is congruent? Yeah. Okay, so let's start this one. So our statements and our reasons. Our first statement, copy that down. Side GK bisects angle J, GM, and GJ is congruent to GM because of the given. Okay, now I know it bisects that angle, but then I have to say, okay, well, since it bisects it, what does that tell me that's helpful? Well, we said that those 2 angles are congruent, so we need to identify those 2 angles. So what are the 2 angles that are congruent? What's the top one? J, G, K. Right? You have to have J, G, K. Angle J, G, K is congruent to, what's the other angle? M, G, K. And remember, you could switch the K to the G, or the K to the M, that would be fine, as long as the G's in the middle. M, G, K. Now, how I know that is because there's an angle bisector. This would just be, this is a definition of angle bisector. So now I have a side and an angle. I need this side right here as well. Okay? What's your next statement going to be? Very good. GK is congruent to GK. How do I know GK is congruent to GK? Reflexive property of congruence. So I have my side, my angle, and my side. Am I done? No? What's the last thing I need to do? Yeah, your proof statement, right? The last statement is going to be triangle GJK is congruent to triangle GMK because side angle side.